Hello everyone. We've built MCP servers. We've connected them to Cursor. Everything works great. But there is something about MCP servers run what might surprise you. Today we're going to build a simple memory server. Watch it fail in an unexpected way and then fix it properly. Let's build something simple, a memory server. It stores key value pairs, so Cursor can remember things across our conversation. We have 4 tools: remember, recall, forget, and list memories. The implementation looks reasonable. We have a Python dictionary called memories, and our tools just read and write to it. Nothing fancy. Let's see it in action. I've already configured Cursor to use our memory server. We can see all our tools available. Now let's see it in action. First, let's try to remember something. It triggers our tool. Now we can ask it back. And see, it triggers the recall tool. Look at this, it works. We can also check all of our memories. Everything works exactly as expected. Or does it? Now watch this. Here we have a second Cursor chat window. Same server configuration, same everything. It checks the tool. It tries to check all the memories. And now look, it forgot everything. In the memories is completely empty, but we just stored the data a minute ago. So what is going on? Here is what's happening. When you use stdio transport, which is what we've been using the whole series, each client connection spawns a separate server process. Chat window 1 started process A. Chat window 2 started process B. Every process has separate memories dictionary. Those are 2 separate Python processes. They do not share memory. They cannot see each other's data. This isn't a bug. It's how stdio transport works by design. Each client gets a fresh, isolated server instance. That's actually good for security. You don't want one user's data leaking to another. But if you do want shared state, you need external storage. Here is the fixed version using Redis. Redis is a database that runs separately from our MCP server. The changes are minimal. Instead of Python dictionary, we connect to the Redis and use our set or our get to store and retrieve data. Also using a key prefix MCP memory, so our keys don't collide with anything else in Redis. You can install Redis in different ways, depending on your system. Homebrew on Mac, Docker, or just install it directly. I already have it running, so let's test it. Now let's see our updated diagram. Both our processes are connected to a single Redis instance. When process A stores data, process B can retrieve this data. Alright, so I've switched the Cursor config to point to our Redis version. So let's try it again. So now in the first chat window, we have something in memory. Now let's check the second chat window. There it is. The second chat can see what was stored in the first chat. Let's try the other way around. And there you go. Here's all of my memories. Now both chats are sharing the same data. That's the power of external storage. Now again, the quick recap. MCP servers with stdio transport spawn separate process per client. In memory state doesn't persist across connections. If you need shared state, use external storage, Redis, a database, even a file. That's all I have for today. Thank you for watching.